Welcome DKP Sogong aboard. Your learning journey starts now. Ever felt like two numbers just happened to be the same? The Birch Swinnerton Dyer conjecture is that feeling but for math. Rank equals vanishing order. Why? This talk flips the script. It's not two numbers matching but one object being read in two ways. We're diving into that source. So what is this magical source object? Think of it as a finite blueprint, a provenance certificate gamma E. It has rules CLE, how things connect iota E, and crucially two windows. Pi are looking at rational points, the arithmetic side, and pi and peeking at local responses, the analytic side. The big idea, infinity isn't packed inside, it's an open door, a template ready for any prime p. No infinite list needed, just a finite rulebook. This finiteness is key. It keeps everything traceable, every local piece tied back to the original equation. It's like having the master key, not all the locks already picked. Now, what happens when we normalize this object? Relations close up, forming finite loops. Those are torsion points, closed channels. But some paths just keep going, never returning to the start. Those are the free provenance channels. Think of them as independent escape routes from the system's core identity. We count these free channels, call it rho of E. Here's the punchline. The arithmetic view sees each free channel as a z direction, giving us the rank. The analytic view at the central point s equals 1 sees each free channel needing its own s-1 factor to vanish faithfully. So both projections read the exact same number, rho of E. It's not coincidence. It's the same underlying structure being seen through different lenses. So we have the arithmetic projection giving us rank E of Q equals rho of E, and the analytic projection giving us odd sub s equals 1 L of E, comma s equals rho of E. What's the grand finale? They are equal. The main theorem states odd sub s equals 1 L of E, comma s equals rho of E equals rank E of Q. How do we know? First, we saturate locally, find those free channels. Then, we show both projections faithfully capture this count without adding or merging anything spurious. Finally, at the analytic center s equals 1, the free channels must manifest as s-1 factors and closed ones as non-zero units. Since the source is complete, there can't be hidden channels or fake factors. Boom! Equality derived from the object's integrity, not by hunting down counterexamples. But wait, there's more. The full BSD conjecture also predicts the coefficient after dividing by s-1 to the power of r. This paper interprets this coefficient as a boundary volume. Think of omega E as the real-world size, reg E as the volume spanned by our free directions, SHA of E counting tricky local global mismatches, and CP accounting for local bumps. It's all about measuring the boundaries of this source object after normalization. So BSD isn't just an equality, it's a deep statement about conservation of structure across arithmetic and analytic views. A fascinating twist on a classic problem.